Hey guys, welcome back. So we are in the functions unit. So one big part of functions is actually function notation. So let's go ahead and write down today's objective. Today's objective is I can use function notation and the vertical line test. All right, now we've been using this word for about a week and a half now, the word function. Now, what does the word function mean? Well, let's write down this definition. Function is a relation in which for each input there's exactly one output. Now what this actually means is that when you have ordered pairs, the x part of the ordered pair does not repeat. So let's go ahead and write this down. The x does not repeat. All right, now you see this new word in here is called relation. Now what a relation is any set of ordered pair xy. So any point, any ordered pair, that's called a relation. Okay, because the reason is because you're relating x to y, so that's why they call them relations. All right, now let's take a look at the relations that are made from these two input and outputs. All right, so now for A, the input is 1, 2, 3, 4. The output is 2, 4, 5. Now, a relation is just an ordered pair. So the first relation we can see comes from 1, and 1 is pointing at 2. So the first relation we have is the point 1, 2, where x is 1 and then the y is 2. Right? The input again represents the x, the output represents the y. The next relation you can see is 2, and then it's pointing at the 4, so the point is 2, 4. The next one is 3, 4. And then finally the last one is 4, 5. Now I have 4 relations here, and I knew I was going to have that ahead of time because of the fact that I have 4 lines over here. Now the next part of it is to answer the question, is this a function? Now remember, over here we said the x does not repeat. So looking at these x's, we have 1, 2, 3, and 4. And as you can see, none of them repeat. Therefore, this is a function. So we're going to put a yes over here. Okay? Now, again, to see a relation, you just look at what we started with and what it's pointing at. That makes a relation. So go ahead and tell me what the relations are going to be for part B. All right, so the relations I got were 1, 5, 1, 7, right? 2, 7, 3, 9, and 4, 9. Okay, those are the relations. Again, we have 5 relations because we have 5 lines over here. Now the question is this a function or not? Let's go ahead and see. Go ahead and answer it for me. All right, in this one it is not a function. Let's see why. So we know that this is a 1, and that's a 1. We got 2, 3, and 4. The fact that we have 1 in the x part twice tells me that this is not a function because, again, x cannot repeat for it to be a function. All right? If you need to go ahead and press pause and write this down, go for it. Otherwise, I'm going to the next slide. All right, now for the vertical line test, let's go ahead and write down the definition of a vertical line test. A relation is a function if and only if no vertical line passes through 2 or more points on the graph. All right, so now vertical, again, vertical is up and down. All right, now what we're going to do is we're going to draw a vertical line and see how many times it hits this graph. Now if I drew the vertical line over here, you can see that it hits it once. If I drew the vertical line over here, again, once. Here, here, and here, you can see that it only hits it once each time. Now, because of this, we can say that this graph is a function. Again, over here it says a relation is a function if and only if no vertical line passes through 2 or more points. And all of these vertical lines, they only pass through once. Now, let's take a look at this one. Sometimes all it takes is one line. And in this case, there's that one line that will tell me if this is a function or not, because it hits the point here and it hits it down here. Therefore, it is not a function. All right. Now, I remember about 3 years ago, one of my students says, why does the vertical line prove that it's not a function? Well, if you can kind of estimate what these points are, I could say that this point is probably the point 3, 1, right? And then this point, let's say it would be 3, negative 5. Okay. Now, the fact that you have 3 in the x category twice, that tells you that it is not a function because the x cannot repeat. Okay? Hopefully you got that. Go ahead and do the next 5 problems on your own. Again, all you're drawing is vertical lines, and you're telling me if it's a function or not. Go ahead and do that right now. All right, for this next one, this is a function because I drew, look, these are all the lines I drew, and in every single one of these lines, you can see that it hits it only once. This next graph right here, all right, this right here is not a function because you can see it hits it twice, so therefore it's not a function. Now this one kind of looks like a scattered plot. Now for this scattered plot, if you draw a line here, 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 and here, we took care of every point on the scattered plot, and you notice that it only goes through one each time you draw that vertical line. Now for this scattered plot, if I draw this one, all right, therefore it could still be a function, but when I draw the very next one, you can see that it hits this point right here, and it hits this point right here, therefore this one is not a function. All right, now over here, sometimes you can draw a line that would kind of make it look like it seems that it is a function because this only hit it once. But if you can draw another line, in that other line you can see 1, 2, I hit it 3 times, therefore it is not a function. So even though there's part of it where it kind of looks like it would be a function, this whole graph would not be a function because of the fact that over here you pass through more than 2 or more points. Okay? Now if you need to press pause, go for it, otherwise I'm going to the next slide. All right, so now we're going to go ahead and deal with function notation. Now, function notation is really easy because all you're really doing is you're replacing y with f parentheses x parentheses. Okay, now what do I mean by that? Well, this is the traditional way you would see an equation, y equals 9x minus 5. All right, now if you were to use function notation, that y disappears, and then you're replaced with f parentheses x parentheses. Okay, so these two things are the same thing. All right, this just has regular notation, this one has function notation. Now function notation, f parentheses x parentheses, the way that you actually read this is you say f of x. So now the way I would actually read this right here would be f of x equals 9x minus 5. Okay, now I want you to do a problem for me in which you're going to plug in a number for x and you're going to find out what y is. So go ahead and do that right now. Alright guys, hopefully you got that right. So now what I ask you to do is I ask you to take this this equation, y equals 9x minus 5, and it says over here that wanted you to put x as a 2. So what you do is you put x as a 2, so by putting parentheses, putting 2 in there, and then you're going to solve this. 9 times 2 is 18, right? 18 minus 5, that gets you 13. Okay, now this is using regular notation. Now what do you know, like say that none of this was here. Okay, let me cover that up. Say that that wasn't there. What you know is that y equals 13. That's all you know. So you only know the output. You do not know what we started with. You probably do because we just did it, but say that it was like 2 weeks from now, you would not know that we plugged in a 2 to get 13. Okay? Now we're going to go ahead and use function notation. Now the way function notation works is, again, this represents the y. But now we're going to replace x with 2. So over here, this x turned into 2. And over here you have an x there and an x there. So when you rewrite this, you're going to put parentheses for that one, and you're going to put parentheses for that one. Let's go ahead and put the 2 in there now. Now this again, this is just function notation. This is just going to come down, all right? And it's always going to come down and it's going to go into the answer as well. Over here, we do the same thing as we did over there. 9 times 2 is 18 minus 5. That's going to get you f of 2 equals 13. Okay, now if this was given to you, if I cover all this up and I asked you what was the input, you could see that the input was 2. You can see it right here, all right, next to the f, all right? And then what would the output be? The output is 13, all right? So that's why we use function notation. Again, let me just say it one more time, all right? If I cover all this up, all right, in the first one over here on the left side, the only thing you know is the output, which is 13. on the right side, you know that the input was 2 and the output was 13. Okay? All right, so now the fact that we know this is that we can also write an ordered pair from this, because you can see the x is 2, and then the y is 13. So here's your ordered pair of 2, 13. Now we're going to do some more function notation on the next slide. If you need to press pause, go for it. Otherwise, I'm going to go ahead and go to the next slide. All right, so here we go. In example B, it says use function notation for the following function. Now over here we have a function f of x equals negative x squared plus 5x minus 3. So there's the function right there. So I rewrote it under the f of 2. Now what we're going to do again is we're going to change these x's, and this time we have 3. We're going to change these x's to parentheses. So over here you're going to have parentheses x, f parentheses equals negative parentheses squared plus 5 parentheses minus 3. You need to write it with parentheses first before you start putting anything in, because you want to make sure that there's no x's there. And as you can see, I have no x's here. Now I can go ahead and put what I want x to be, which is that 2 right there. So let's go ahead and put the 2 right here, and right here. Now again, this is just going to come down, and that's always going to come down till we get to our answer. Over here, you can actually plug this whole thing in your calculator. Now what you would be plugging in would be negative parentheses 2 parentheses squared plus 5 parentheses 2 parentheses minus 3. Alright, now if you want to do it in your head, you can kind of break this down over here. This negative 2 squared is really negative 4. 5 times 2 is 10, so we get negative 4 plus 10 minus 3. Combine all these together, and you end up getting f of 2 equals 3. All right, now again, the input is 2. That's what they told me they wanted. The output is, which I found for them, is the 3. So the ordered pair that would coincide with this would be the point 2, 3 as an ordered pair. Okay? All right, I want you to try the next two on your own. Again, you got to make parentheses first. Then you have to plug in the number, and then simplify the right side. The left side is just going to come down. So for B, we have f of negative 1. Go ahead and do this one. So hopefully you got this one correct. Now again, we're going to take this function and we're going to rewrite it with parentheses. So it's going to be f parentheses equals, you see how there's a negative in front of this x, so we're going to put negative in front of the parentheses. We're going to square the parentheses, plus 5 times parentheses minus 3. Now that I can see there's no x's here, we're going to go ahead and put the negative 1 in there. We'll put negative 1 right there, there, and right there. All right, now, again, you can plug this whole thing in your calculator, and if you didn't have a calculator, you can just go ahead and do these individually in your head. Negative 1 squared is 1 times negative 1 is negative 1. 5 times negative 1 is a negative 5, and then we're going to bring down the minus 3. Put these together, you're going to wind up getting f of negative 1 equals negative 9. So we simplified it, and now we can see that the input was negative 1, the output was negative 9. Therefore, the ordered pair that would coincide with this would be in the third quadrant. Okay. The next one for C, let's go ahead and do that right now. C is f of 0. I want you guys to try this one on your own, and then we'll go over it. Give you guys a few seconds. Go ahead and do that. All right, so hopefully you got this one correct. So we're going to take this function again. We're going to take these 3 x's and change them to parentheses. We're going to put 0 in all of them. So f of 0 equals negative 0 squared plus 5 times 0 minus 3. These two right here just turn into zeros anyway. So 0 plus 0 minus 3, that's going to get you negative 3. Okay? So this right here would be the answer, and the ordered pair that we would call this one would be the point 0, negative 3. Again, because 0 is the x, which is what we put in there, and then negative 3 is the outcome, and the outcome is y. Alright guys, in example C, we have 4 different kinds of ways that you can read a function. Okay, we just did some experience with this, so I want you guys to try this one on your own. This is the function, alright, in function notation, and they want you to find f of 3. Go ahead and do that right now, and then we'll go over it. All right, so we're going to rewrite this function with parentheses. So f parentheses equals 3 parentheses minus 7. We're going to go ahead and put in the 3's. This is going to come down because, again, this is function notation. This is just telling me what the input is. So f of 3 equals 9 minus 7. F of 3 equals 2. We're done. We simplified it, so that's the answer. And this goes with the ordered pair 3, 2. Okay, 3 and then 2. 3 is the x, 2 is the y. Okay, now this one right here, again, we're still looking for f of 3. And again, 3 represents the x. So for part B, figure out what the y is if the x is 3. Go ahead and do that right now. All right, now for this one, again, we see that we're looking for f of 3, and 3 represents x. Now over here, we have 4 x's, but the one that has a 3 in for the x is this one over here. So what we're going to do is we're going to locate, for f of 3, we're going to locate where x equals 3. The y is just whatever's right next to it, because the y is 1, so f of 3 equals 1. So that's the answer. And remember, the ordered pair that goes with this is the point, this is first, right? So it's 3, 1, and you can see that's what we have here anyway. All right? All right, now the next one is like what we did on the front. The question is, what is the ordered pair of f of 3? So you got to find f of 3 over here. Go ahead and do that right now. All right, so hopefully you got this one right. Now the 3 is over here. What is it pointing at? It's pointing at 5. So since 3 is pointing at 5, we know that f of 3 equals 5. So the ordered pair that goes with this would be the point 3, 5. All right? Now here's the last one. Again, you have to find f of 3. And again, this 3 represents x. You have to find out y. Go ahead. All right, so now, again, this represents that x equals 3. Now, since this is the x-axis, we know that 3 is right here. Now all we got to do is find the y that goes with this 3. So we're going to go up to the actual graph right here. This point right here is going to be the point 3, 4. So we know that the y equals 4. Okay, so you go up and then you see what the y is. The y is pointing at the 4. Therefore, f of 3 equals 4. And the ordered pair would be the ordered pair 3, 4. And as you can see, this graph is touching the point 3, 4. All right, so hopefully you understood. We're going to get some practice on this tomorrow. You guys have a good night. See ya.